This is PreCalculus 12, Chapter 4.1. We're going to be looking at combining functions. We're going to start off doing this graphically. We're going to do adding, subtracting, multiplying, and dividing. Let's look at adding. So h of x is equal to f of x plus g of x. We have f of x here. We have g of x here. Let's look at the domain and ranges. So the domain of f is negative 5.2 to about 9. And the range is negative 2 to about 3.6. And for g, we have negative 1.5 to 9, and negative 1 to about 2.4. To perform the addition, we can take any two x values, find the y values, and add them together. However, to get an accurate graph, it's good to use key points. So a key point is where f of x equals 0. And if we have f of x equal to 0, we have h of x equals 0 plus g of x. And that's just g of x. And that's how we arrive here. Similarly, if we can do g of x equal to 0, and then we get h of x equals f of x. Here's another key point. F of x equals negative g of x. So let's look at that. H of x equals negative g of x, where we're substituting, plus g of x equals 0. Even if you don't remember, you can derive them from simple properties. So h of x equals 0. We also want to test endpoints, and we also want to test grid points if they exist. You're not always going to be able to find grid points for both functions. But if you can use it. So let's look at the domain of h of x. The domain of h is limited to the most restrictive domain. This domain is smaller, so it's more restrictive. If we look at x equals negative 3, we can find an f, but we can't do g of negative 3 because it doesn't exist. So use most restrictive. Negative 1.5 is less than or equal to x is less than or equal to 9. And the range. We'll have to determine the range at a later point. And the note for key points is we want to plot easy points. Okay, so let's start with the endpoints. So we have an endpoint here, and we have negative about 0.8 and negative 1.7. So this is roughly negative 2.5. Here we have a 0. F of x is 0, so h of x is going to be g of x. And here we have another 0, that's g of x, so h of x is going to be equal to f of x. And here we have endpoints. This is 2.4, this is 3.6, so we're going to plot at 6. 1, 2, 3, 4, 5, 6. Okay, and we have this other one where f of x equals negative g of x. So we're looking for points that are equidistant from the x-axis. So these are both on the same side, so that's not going to matter. And over here, they're on the same side. I should put a mark there. So here, they're on opposite sides, so we can check for equidistant. And roughly about here and here, so we have 0. Okay, now we can smoothly join the points. And that's our h of x. Now we can compute the range, roughly negative 2.5. And this is 6. Let's look at subtracting. So h of x is going to be f of x minus g of x. It doesn't necessarily have to be these letters, but it'll be in this format. And we have the same f and g. So again, our domain is going to be negative 1.5, so less than or equal to x, less than or equal to 9. Again, it's the most restrictive domain. So we're going from here to here. So the key points, slightly different. When f of x or g of x equals 0, these are easy to derive. We just substitute like we did before. And there's a slightly different key point here. We're looking for f of x equals g of x because h of x equals g of x minus g of x equals 0. Okay? And again, we want grid points, if available. Okay, again, we start with the endpoints. So 1.7, negative, and negative 0.8, negative 1.7, negative 0.8. And we're doing f minus g. So that's roughly 0.9. And we're looking for f and g equal to 0. F is equal to 0 here. So we have negative g of x. So we just reflect this point up here. And over here, we have g of x equals 0. That one's simpler. It's just f of x. And again, we have 3.6, 2.4. I think it shifted on this, but we'll say it's 2.4. So 3.6 minus 2.4 is 1.2, and we have our point there. And we can look for where f and g are equal. That's here, and that's 0. And now we can smoothly join our points. And we can estimate our range. We have negative 0.9. And it looks like our maximum is about 2.9. And I don't see any easy grid points. So we're complete. Next example, multiplying. Lots of key points with multiplying. H of x equals f of x times g of x. And these are easy to derive. If f of x equals 0, then h of x is going to be 0. If g of x is going to be 0, h of x is 0, because 0 times anything is 0. If f of x is 1, then it's just 1 times g of x, so we have g of x. If g of x is 1, similarly, h of x is going to be f of x. And we have a couple more. When it's negative 1, we just reflect g of x on the x-axis. And if g of x is negative 1, we reflect f of x on the x-axis. And again, grid points as well as endpoints. Domain is the same, negative 1.5 to 9. And again, we'll do the range afterwards, after we finish our plot. So we start at the endpoints. We have negative 0.7 times negative 1.8. And we'll bring up a calculator. I know it's going to be positive, so I'm just going to leave out the signs. and that's roughly 1 1/4. 1 1/4. Okay, we're looking for zeros. Here's a 0, and it's going to be 0. Here's a 0, and it's going to be 0. Now let's look for ones. We just go through the list. Here's a 1, so it's just going to be g of x. Here's a 1, so it's just going to be f of x. And this one doesn't quite reach -1. Here's a -1, so we take g of x, which is about -0.9, and make it 0.9. And that completes all our key points. So now we can just draw a curve through all these points. Again, we're estimating, and of course I missed this endpoint, 3.6, 2.4, bring up the calculator, 3.6 times 2.4, and we get 8.6. 1, 2, 3, 4, 5, 6, 7, 8.6. And h of x. So we have our minimum looks like it's around -1. And 8.6. And that's all we have to do for multiply. Dividing. This is the trickiest one because now we have non-permissible values, and they can be wholes or they can be vertical asymptotes. Our domain, we'll say it's -1.5 to 9 again, but we do have a restriction, and that's where g of x equals 0. So I'll put a mark there, and it can't equal 4. Okay, let's look at our key points. If we have 0 divided by g of x, it's 0. If we have g of x equals 0 and f of x equals 0, that means something canceled out, and that's a whole. If we have g of x equals 0 and f of x does not equal 0, that means something did not cancel out, and then we have a vertical asymptote. And if g of x equals 1, that means we're just doing f of x divided by 1, which is f of x. And similarly, if we have g of x equal to -1, it's just negative f of x. If f and g are equal, then we have h of x equals to 1. And if f is the negation of g of x, then h of x equals -1. Again, we have endpoints and grid points. Let's start at the endpoints. -1.8, -0.7. So -1.8 divided by 0.7. I know it's going to be positive, so I'm going to leave the signs out. And we have 2.6. 2.6. And 3.6 divided by 2.4. And we get 1.5. So 1.5. Okay, we're looking for f equal to 0. That's here. And it's just going to be 0. Now we're looking for g equal to 0. That's here. And because this is not 0, we have a vertical asymptote. Vertical asymptote, x equals 4. Okay, g of x equals 1. G of x equals 1, so it's just f of x. G of x equals -1. We don't have that. F and g are equal. F and g are equal here, so that is 1. F and G are opposite on the x-axis. That occurs roughly here and here. So we plot -1. And we've covered all the key points. So we can just smoothly draw this. We know it's a vertical asymptote, so we need to go to the asymptote. Here, now we need to decide, is it going to go this way to the asymptote or this way to the asymptote? It's not a guess. Yes, this line is going to continue, but let's look at this. This is a positive value divided by a very small positive value. So this is going to be at positive infinity. And similarly, if we look at this, this is a positive value divided by a small negative value, so it should go to negative infinity. And we can determine the range now. It's all reals, because this goes to infinity, and this goes to negative infinity, and they overlap, so there's no gaps. So in general, it's difficult to say anything about the combined range, because the max and min of one function may not correspond to the max and min of the other function. So if it's really hard, just graph it and find your range, or you can use your calculator to estimate. But we can make some generalizations for the combined domain. It's the most restrictive. So where the two domains overlap. So here's an example, a slightly different example. We have our number line, 0, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So the domain of f goes from -2 to 3. And recall that if this is less than or equal, we put a solid dot. If it was just less than, it would be an open dot. And for g, we have -5, 1, 2, 3, 4, 5, all the way to 1. And then for the domain of f plus g, or any operator, it's where they overlap. So they overlap from here to here. So -2 to 1. And for division, there's going to be NPVs when g of x equals 0. And again, it'll be a vertical asymptote or a hole. And recall that 0 over 0 is going to be the hole. So watch out for this on question 1D of your assigned work. You can use a table of values. However, you might miss NPVs or other key points. I think it's not too much work to derive the key points on a test, because they're simple mathematics properties, but I'll let you decide once you do some work. And that completes this lesson.